4, 3, 2, 1. You have been watching the launch last February of SpaceX's Falcon 9 Heavy rocket and the dramatic and safe return of 2 of its 3 main engines. A truly remarkable achievement. However, to paraphrase Winston Churchill, this is not the end of space launch development, nor is it the beginning of the end. It is, perhaps, the end of the beginning. If this is so, then what next? Well, my name is John Hollaway, and I will tell you here about what I believe will be the next major step in mankind's conquest of space. It will be the attainment of what has been the holy grail of space for perhaps half a century or more, the creation of a single-stage to orbit, fully reusable spaceplane. This is called the Swala spaceplane, and I would like to explain it to you, and also why this breakthrough is happening now. Over the last 50 years, this holy grail, a spacecraft that flies up and down like an aeroplane, has been sought by the white knights of the space industry. But alas, to no avail. Here are some of their broken lances. The thing to note about all of these attempts is that they are essentially rockets. This is understandable, for they were all designed by rocket engineers, and in consequence they all depend on the same technology in use since the Second World War. That is, they carry up with them their own oxygen through an atmosphere containing oxygen. Consequently, in a situation where every extra gram of weight requires about another 5 grams of rocket fuel, they further hampered their chance of success by having to carry up over 10 grams of oxygen as well. Significantly, almost all, perhaps all, of these attempts overran their budgets and schedules, and certainly none demonstrated that they were able to perform as single-stage to orbit reusable launch vehicles. Which brings us to this. The Swala, SSTORLV. Not designed by a rocket engineer. Why the name Swala? It is the Swahili word for a gazelle, and the concept arose because of my distress on hearing of the Challenger space shuttle disaster while I was working on a gold mine in a remote part of Africa. To send people up atop a flying bomb of fuel and liquid oxygen seemed like madness. There must be a better way. That was back in January 1986, and for many years I chewed this over, slowly evolving the Swala concept until it was able to withstand all the technical and economic challenges thrown at it, and they were many. I am actually extremely grateful for the technical guidance and the other help the space community has given me during this time. And what you see now is the outcome of many years of discussion and development. But before I show why the Swala spaceplane will work and something like 60 others have not, let me explain what they were up against in a bit more detail. First, come what may, Swala is going to need the services of rocket engineers for the last and major part of its journey into space, because rockets are still the only practical propulsion method up there. Here is the relevant bit of the Swala concept. But if you want to keep the rocket part of Swala small enough to be a single stage, you need a vehicle that is already very high and going very fast before its rockets start to work. The problem is that jet engines don't function much above 15 kilometers. You can attach a rocket to a balloon, these are called rockoons, and a balloon will carry the rocket to well above that. However, it will only give you height, not speed, and you're going to need both if you're to get away with only a single-stage rocket motor. This is where you have to turn to a propulsion device called a ramjet. Here it is, and you can see why it is sometimes called the flying stovepipe. The Swala vehicle uses 2 such ramjets. Now, there is a firm view in the rocket industry that while ramjets are enormously powerful, they're only good above the speed of sound, which is Mach 1 or about 1200 kilometers per hour at sea level. The reality is that yes, while ramjets only generate a fraction of their potential thrust at, shall we say, 400 kilometers an hour, this still amounts to close to the thrust produced by a solid fuel rocket, like the one that the Swala vehicle carries up with it. But how to get the vehicle to 400 kilometers an hour in the first place? This is done by mounting it on a carriage which is propelled by what is known as a linear motor. Think of an electric motor open up flat. This system, which has been in use for many years in, for example, roller coaster rides, is being installed in aircraft carriers in America and now Russia and China. Here are jet aircraft being launched during the initial land-based tests of the system in the United States. These are Super Hornet fighter bombers of the US Navy, and by now several hundred successful launches have been completed in sea trials. The technology is known as EMALS, standing for Electromagnetic Aircraft Launch System, and it can accelerate a fully loaded 45-ton aircraft to 240 kilometers an hour in just 90 meters. The Swala launch track will probably be more than a kilometer long, not just because it has to launch faster, but because on landing, when the vehicle is settling back onto a carriage which has matched its speed, it may need extra track for safety. Incidentally, doubts have been expressed as to whether this Swala landing and capture system is practicable. The instrument landing experts say it is. Indeed, the US Navy is already doing something rather like this with its 14-ton X-47B drones, as you can see from this clip. We have got a bit ahead of ourselves. To come back to the ramjets, there is a problem with them, which is the formation of what is called a shock front, once the vehicle is travelling above about Mach 2. This has the effect of throttling ramjet performance. It can be overcome by putting a chin, as it is called, above the ramjet inlet to break it up. To show you what is meant by this, here is a picture of Boeing's Advanced Strategic Air Launch Missile, with its ramjet inlet below the chin. Just how well this worked was unintentionally demonstrated when the fuel control failed and it accelerated up to Mach 5.5 before it ran dry. This chin is achieved on the Swala vehicle by a fairing under the wings and above the inlet, as you can see here. But now, the really key part of the Swala scheme is that the ramjets and their fairings are parachuted back for reuse when the air becomes too thin for them to work. Since they alone will weigh about as much as the empty vehicle, this weight saving is the critical trick for keeping the solid fuel motor to a single stage. That holy grail, again. You can get an idea of what the return of the Swala vehicle would look like from this clip of the landing of the X-37B, the United States Department of Defense's own spaceplane. And note that it was launched into orbit by a big, conventional and expendable Atlas V rocket. But, unlike the X-37B, no undercarriage is needed for landing the Swala vehicle. The linear motor trolley that it descends on provides this, thus saving yet more launch weight. So, all that comes back to Earth of Swala is an empty shell. As a result, it will have what is called a low ballistic coefficient, meaning that it can fly back down to Earth relatively slowly. This allows light carbon tiles to be used to prevent the heat generated during re-entry from damaging vulnerable parts, like the underside of the wings, the nose and the leading edges. The X-37B is another vehicle with a low ballistic coefficient and using carbon tiles, as you can see from this picture. So there you have it, a single stage to orbit reusable launch vehicle that will attain the goal that has been sought in vain for the last 50-odd years. The Swala vehicle can put up to half a ton of payload into low Earth orbit and can do so on call and with only a day or so's notice. I hope you can now understand just what a unique achievement this is. You might like to visit the website at www.swalarlv.com, but in the meantime, thank you for listening. Oh, and one last point. Swala uses 3 propulsion systems to achieve its goal, something that rocket engineers think is complex and therefore untrustworthy. But have you noticed that there are no moving parts in any of them? Thank you again.